3D computer graphics are graphics that use a three-dimensional representation of geometric data that is stored in the computer for the purposes of performing calculations and rendering 2D images. Such images may be stored for viewing later or displayed in real time. 3D computer graphics rely on many of the same algorithms as 2D computer vector graphics in the wireframe model and 2D computer raster graphics in the final render display. In computer graphics software, the distinction between 2D and 3D is occasionally blurred. 2D applications may use 3D techniques to achieve effects such as lighting, and 3D may use 2D rendering techniques. 3D computer graphics are often referred to as 3D models. Apart from the rendered graphic, the model is contained within the graphical data file. However, there are differences. A 3D model is the mathematical representation of any three-dimensional object. A model is not technically a graphic until it is displayed. A model can be displayed visually as a two-dimensional image through a process called 3D rendering or used in non-graphical computer simulations and calculations. With 3D printing, 3D models are similarly rendered into a 3D physical representation of the model, with limitations to how accurate the rendering can match the virtual model. History. William Fetter was credited with coining the term computer graphics in 1961 to describe his work at Boeing. One of the first displays of computer animation was Future World, which included an animation of a human face and a hand that had originally appeared in the 1971 experimental short A Computer Animated Hand, created by University of Utah students Edwin Catmull and Fred Park. Overview. 3D computer graphics creation falls into three basic phases. 3D modeling, the process of forming a computer model of an object's shape, layout and animation, the motion and placement of objects within a scene. 3D rendering, the computer calculations that, based on light placement, surface types, and other qualities, generate the image. Modeling, the model describes the process of forming the shape of an object. The two most common sources of 3D models are those that an artist or engineer originates on the computer with some kind of 3D modeling tool, and models scanned into a computer from real-world objects. Models can also be produced procedurally or via physical simulation. Basically, a 3D model is formed from points called vertices that define the shape and form polygons. A polygon is an area formed from at least three vertexes. A 4-point polygon is called a quad, and a polygon of more than 4 points is an n-gon. The overall integrity of the model and its suitability to use in animation depend on the structure of the polygons. Layout and animation. Before rendering into an image, objects must be laid out in a scene. This defines spatial relationships between objects, including location and size. Animation refers to the temporal description of an object. These techniques are often used in combination. As with animation, physical simulation also specifies motion. Rendering converts a model into an image either by simulating light transport to get photorealistic images, or by applying an art style as in non-photorealistic rendering. The two basic operations in realistic rendering are transport and scattering. This step is usually performed using 3D computer graphics software or a 3D graphics API. Altering the scene into a suitable form for rendering also involves 3D projection, which displays a three-dimensional image in 2 dimensions. Communities. There are a multitude of websites designed to help educate and support 3D graphic artists. Some are managed by software developers and content providers, but there are standalone sites as well. These communities allow for members to seek advice, post tutorials, provide product reviews or post examples of their own work. Differences with other types of computer graphics. Distinction from photorealistic 2D graphics. Not all computer graphics that appear 3D are based on a wireframe model. 2D computer graphics with 3D photorealistic effects are often achieved without wireframe modeling and are sometimes indistinguishable in the final form. Some graphic art software includes filters that can be applied to 2D vector graphics or 2D raster graphics on transparent layers. Visual artists may also copy or visualize 3D effects and manually render photorealistic effects without the use of filters. Pseudo 3D and true 3D. Some video games use restricted projections of three-dimensional environments, such as isometric graphics or virtual cameras with fixed angles, either as a way to improve performance of the game engine, or for stylistic and gameplay concerns. Such games are said to use pseudo 3D graphics. By contrast, games using 3D computer graphics without such restrictions are said to use true 3D.